So as you substitute through, well, what's 1 divided by negative 2? Get negative 1/2. Okay? What's 1 divided by negative 1? Negative 1. Very good. What's 1 divided by 0? Error. Undefined. What happens when you divide by 0? What do you show graphically? Do you remember? Talk a little bit about it. Asymptote, remember that? An asymptote. Now, if the value of x generates a value of y that happens to be undefined, that means you have what's called a vertical asymptote at 0. Because the asymptote is where x, or where your denominator is 0. Okay. Bless you. Welcome. And then you continue on. You get 1 divided by 1 and 1 divided by 2. Okay. And we've learned to plot these points. If you need to go get a drink, go for it. So at negative 2, my y value is negative 1/2. Here-ish. Negative 1, negative 1. Here-ish. Watch what happens as you get closer to 0. What's a number that's smaller than negative 1 getting closer to 0? I'm sorry, bigger than negative 1 getting closer to 0? Negative 1/2. If I pick and I divide 1 divided by... Just go away. Sorry. I do 1 divided by negative 1/2. What do you get? Which is? Remember, this means 1 divided by negative 1/2, which is the same as 1 times negative 2. Remember working with fractions like that? No? You don't remember working with fractions like that? When you're working with fractions, this is called a complex fraction. A complex fraction is just basically fraction divided by fraction. If you think about it in terms of what this means instead of vertical, this is the same thing as saying 1 divided by negative 1/2. And when you're dividing, you're actually multiplying by its reciprocal. So that's what's going on here. So we see a lot of this. We do a ton of this throughout the course of this chapter. So if I'm at negative 1/2, I'm down at 2, negative 2. My curve, what it's doing is it's getting infinitely closer here and infinitely closer there. Okay? Because if I pick numbers that are bigger than or smaller than negative 2, like negative 4, I get 1 over negative 4, 1 4, negative 1 4, negative 1/5, negative 1/6, negative 1/100th, and so on and so on. Yes, sir? Okay. So I'm going to get infinitely closer and closer and closer to the x-axis, as well as infinitely closer and closer and closer to the y-axis. And it happens to be the same thing on the other side. At 2, we are at 1/2. At 1, we're at 1. If I'm at 1/2, I'll be up at 2. And I get this curve. This curve value this way. 2 curves, yeah. 1 on each side. Basically, what's happening here is that we're creating a hyperbola. We're creating a hyperbola that is not just straight across from one another or vertical with one another. It's not a conic section like that. It's a hyperbola in 2 separate quadrants. Okay, it's a hyperbola brought into 2 quadrants. Now, these 2 quadrants I'm talking about, in this case, just happens to be bound by the x and y axis. Eventually, this could turn into a shifted value where our x and y grid could be over here, and this has just been moved. Yes, sir? Half. I was just showing how it bounces down to 2. So we get that. So we're talking today about this whole idea of a polynomial divided by a polynomial. And all of these things are going to have some form of generic equation. And you're going to see this thing called a hyperbola, which we've looked at some point. I know we have. But we get this mirrored image across the axis. Okay? And you need to have a couple of points to tell whether it's bouncing down this way or it could be bouncing up this way, depending upon the problem. Okay? Which is nice then, because there is a generic formula. There's a lot of words here for things we don't have to worry so much about. So let me show you this. I'm looking at what's called the hyperbola. The hyperbola that we just graphed, I'm just going to draw it off here just off the side. We just drew a hyperbola that looked like that. We had a horizontal asymptote, getting closer here. We had a vertical asymptote because it was getting infinitely closer and closer there. Now, what happens then is that you get this idea of what's called domain and range. Remember we talked about domain and range before? Domain go with which ones, the x's or the y's? X's, you remember why? What comes first in the alphabet, domain or range? Domain, what comes first, x or y? X. It's a stupid thing, but you'll remember, if you remember it that way, it's kind of nice. It's kind of a cheesy way to remember it. So we have horizontal and vertical asymptotes. The domain and range are going to be all non-zero real numbers. Basically, everything except your asymptotes. And I'm going to show you guys as we get into a real example with like the whole kit caboodle going on about how we solve things. And what you were talking about a second ago, Mr. Ward, was that are there going to be two parts to this? Yes, because you have two sides of a vertical asymptote. You have numbers that were, in this case, negative. You have numbers on the other side that were positive that generate different boundaries of the curve. All right? It's just a matter of when we go back and think about what we do with conic sections, we're looking at specific ordered pairs. They had twins on either side. This is kind of the same idea. You get the symmetric-ish twin if you're bound across the axis. We'll move everything around a little bit and mess it up a little, but in essence, it works out to be really easy to work with. Okay? So let me show you this generic formula. And a lot of times that helps out a lot. We have this generic formula here. Y equals A divided by x minus h plus k. So what do you think the h and k stand for? Horizontal and vertical. Some sort of a shift there. Huh? Just kind of reminding you guys here. Now, what's happening here is that you get asymptotes. If you look at the generic term here, the generic equation, x minus h. X minus h is a term. The term generates a zero. The zero of x minus h would be at h. So in this case here, if it's x plus 3 as a term, what's the zero? So that means I have a vertical asymptote at negative 3, because you can't have negative 3, otherwise it becomes an undefined function. That's where that comes from. Okay? It's using terms and looking back at zeros. Right? So just like we have done in the past, a lot of this stuff, remember when we worked with conics especially, I always like to label out everything that we knew, A, H's, and K's. By doing that, it made our lives easier to be able to substitute in what values went where. So I did the same thing. So if I have this equation of y equals negative 2 divided by x plus 3, all subtract 1, I can take that info and I can figure out what my A value is, my H, and my K. What's my A value here? Negative 2. What's my H value? And my K value? Negative 1. So I have negative 2 for A, negative 3 for H, negative 1 for K. that tells me right away that I have a vertical asymptote at x equals -3, and I have a horizontal asymptote at y equals -1, because of this rule here. Okay? Because of that rule. It tells you where your horizontal and your vertical asymptotes will be at your h's and k's. I want you to think of that h and k then as your new boundary area that you're going to pick points. Okay. Let me slide this around and put this on a clean one here. So let's see. Let's move this up. Bless you. Let's move this over here out of the way, and I'm going to use the space bar. So if I start out my graphs like I do normally, I start with just a regular generic XY grid. The first thing I'm always going to plot for these are my asymptotes. My vertical asymptote is at, what is it, -3? My horizontal asymptote is at -1. We all right with that? Run out of lead. Does anybody help the poor guy out? I have an expo marker you can use. No, I just have to see. I have to see you going. So just like we did a second ago, remember how in that first problem we picked values that are bound across the x-axis or the vertical axis there? We picked, -2, -1, 0, 1, and 2. Well, now I know that my asymptote's at -3. I'm going to pick two numbers to the left of it and two numbers to the right of it, substitute in for x to generate the y. That's all we have to do. What just happened? I moved my original graph would have been at 0, 0. Are we okay with that? What I did was I moved the horizontal and vertical. I moved it for my asymptote. So my asymptote, my vertical asymptote, to generate what we call the 0 of the denominator, what it can't be, is at -3. So what are two numbers smaller than -3? -4 and -5. What are two numbers bigger than -3? -2 and -1. Usually what happens is if you pick the two numbers to the left and to the right of your vertical asymptote, you're always going to get easy numbers to work with. Easy-ish. Right? So I pick -4, 2. What's -4 plus 3? What's -2 divided by -1? 2. What's 2 minus 1? It's 1. So then at -4, that means I get 1. I do that again with -5. What's -5 plus 3? -2 divided by -2. 1. What's 1 minus 1? 0. So that means at 5, it's 0. So right there, by looking at those 2 points, I can now determine the direction of that curve. See how it's, if I'm moving from left to right, it's going to be increasing from one asymptote to the other? It has to do this. Yes, ma'am? 2 points on both sides. All right, 2 points on both sides. It's going to be really easy to see how this stuff plots itself through. Don't get me wrong, you might get like a half Z here or there, but you want to do the next 2 points because you're always going to be, that's how you're able to tell what direction things are moving. And that's why you'll also be able to tell what the quadrant-ish thing is. It's not technically a quadrant, but where it's going to fall into play within all the asymptotes. And do it on the other side then. -2. What's -2 plus 3? 1. Negative 2 divided by 1. Negative 2 minus 1. So then at negative 2, we're at negative 3. Do it again with negative 1. And there I think you get negative 2. You get negative 2. And notice how this one's moving up and to the right. They should be symmetrical across each other. They should be able to fold into one another to make it work. Okay? And that's how you would plot that. Now, in this case, what is the value of x that it can't be? Right, and what's the value of y that it can't be? Negative 1. So when I go to talk about what's called the domain and range, I would list my domain. My domain is all values of x such that x does not equal negative 3. That's called set notation. It basically means where can't x be, or what value of x can't you have. And it's just a fancy way of writing it. So your domain is all values of x. That vertical upright stands for such that x can't equal negative 3. And for the range, it would be all values of y such that y is not equal to negative 1. Excuse me. It's not a real tough thing because there's a process and it's procedural, and you're going to do the same thing over and over and over again. Okay. Yeah? Yeah. All right. So that's one way we're going to look at it today. We have one other generic form to look at as well. We'll have a form that looks like this. Can I go to anyone? I don't know if anybody's still writing that out. We're going to have another form that looks like this. We'll have y equals ax. Oops. We'll have this generic form that looks like this. Ax plus b over cx plus d. Think of this as linear equation divided by linear equation. Think of it that way. Okay? Slope-intercept form divided by slope-intercept form. Mx plus b over mx plus b. Does that make a little bit of sense? Where you still have that value of x, you still have some constants involved, you still have a coefficient of the value of x. What happens with this is that your zero, your vertical asymptote, the vertical asymptote is when you take your cx plus d equal to 0. It's the zero of the denominator. So if my denominator happened to be 3x minus 4, my vertical asymptote would be where? What's the zero of 3x minus 4? Was it 4/3? Yeah, exactly. So it's the same idea that you have a term, you're finding the zero. So we're using a lot of the same lingo that we had in the past when it comes to setting these things out. Looking at the rationals, we're looking at the zeros of the denominator. Why look at the factor, or what the terms are of, or sorry, the zeros of the factor form. And then your horizontal asymptote are just going to be wind up being coefficient divided by coefficient. Again, this is going to be super easy to see when we get an example of how it works. Really, really simple to work. Let me show you. I don't like graph paper. Let's do this one. Y equals x plus 1 divided by 2x minus 4. And you notice how very quickly it's easy to tell which of these two forms you're going to be working with? you have 2 values of x here. The other one, you only had 1 value of x. Mara will throw everything. So first thing you want to do is find the 0 of the denominator. What can't x be? 2. So my vertical asymptote is going to be at x equals 2. My horizontal asymptote is going to be at y equals, well, what are the coefficients here? What's the coefficient of the numerator? 1. What's the coefficient of the denominator? 2. So your asymptote's at 1/2. Okay. What's wrong, Nelson? What's the coefficient of the numerator? 1. Let me rephrase it. What's the coefficient of the x in the numerator? 1. What's the coefficient of x in the denominator? So your fraction is 1/2. Nope. You just look at the coefficient. Remember, the horizontal asymptotes for this will always be at y equals a over c. Just the coefficients. It'll always be that. Okay? It'll always be that. Because that's the way that this form looks. Think of it as like when we have linear forms here. So you start by plotting it then. Vertical asymptote at 2. Horizontal asymptote. Okay. What numbers do you think you're going to wind up picking? What numbers are you going to wind up picking to put in the table? My table, I'm going to pick 2 to the left and 2 to the right. 1, 0, 3, and 4. Pick 2 to the left and 2 to the right of your vertical asymptote so you know where your boundaries wind up going to. Yes, sir? What's that? Oh, but remember, I'm picking values of x. Yeah, you always pick values of x to generate y. Because your function is y. Y equals. So you pick values, because if a function, that means there's a singular input to generate an output. So your singular input is your x input, y is your output. Okay. Domain drives the range. So if I pick 1, what's 1 plus 1? 2. I get 1 plus 1 over 2 times 1 minus 4. So what's 2 minus 4? So what's 2 divided by -2? -1. So at 1, I'm at -1. You okay with that? At 0, well, we get 0 plus 1. Hi, Devin! Odds! At 0, what do you get? -1/4. Good. At 0, you get -1/4. Which means at 0, I'm up getting closer to here. So between those 2 points then, can you tell what direction this is moving? Yep, exactly. It's moving up and to the left. That's why you need 2 points to figure out what direction you're going. Okay? And I check them on the other side. I check it at 3. I get 3 plus 1 over 2 times 3 is 4. That's 4 divided by 2, I believe. And you get 2. Should this next point be above that or below that, do you think? It should be below, because remember, it's got to mirror the other side. So if the other side's moving down to the right, the other one has to be moving. So I try it again. I get 4 plus 1 over 2 times 4 minus 4. That's 5 fourths. 5 fourths is what? 1 1/4. So it's a smidge larger than 1. So, and just like we said, it's going to follow. That's what allows you to tell direction. You need 2 points on either side. It's very, very, very similar to every other way or every other time that we learned a graph. We just pick 2 points on both sides of an axis. In this case, we're moving our axis via the vertical asymptote because of that shift. That's where this comes from. Not too terrible, is it? And a lot of times with this stuff, it's direct substitution to generate your points. And if you notice right away that your points are flipping over axes or over your asymptotes, that means you missed the sign somewhere. That's usually what people will screw up with some of this stuff. It's the arithmetic by pressing the wrong button or missing a negative symbol here and there. It's what will mess it up. It's not the actual process. Do you want another example? You say that to anything. I'd say, do you want another dollar? Yes, ma'am. Absolutely. Here, I got you $1. All right, let's do this. Where's your asymptotes? Oh, I forgot to do domain and range. I'm sorry. Let me do that real quick. Domain and range. What can't x be? 2. So my domain would be J little space x such that x does not equal 2 and J little space. The brackets? Oh yeah, I went to college, man. We had to write brackets for everything. I'm getting you accustomed to seeing set notation. You'll see it a lot more as we go on. It takes practice. I used to not pay attention in class. Go figure, me not pay attention to something. And I would, we would try and practice drawing set notation. None of us could make the brackets the right way. Well, think of it as J Leno's face. So I got this car. It does 700 miles an hour. I got my jean shirts on. See, it's J Leno's face. That's where I'm getting it. It's J Leno's face with the hair. So J Leno's face, y, such that y, what was it, half? And then J Leno looking the other way. Because it's brackets. That is the norm. All right. I guess the normal way would be. No, I can't even do the normal way because I'm so used to doing the jam. That's the normal way? I don't know. Remember our y, our horizontal asymptote? That's where our y value comes from. Yep. Your domain and range are restricted by your asymptotes. That's where you get your restriction. Your domain restriction will always be x equals some the x value. The range restriction is your y value. Nelson. Well, pick up one. I call it blue. Sorry, I didn't see like turquoise. C. I just wrote blue out. Why are you shaking your head in disappointment? Jerk. Fine. I think I posted it. It was on page 544. Does that sound right? Was it? I think it's 28 through 40 even. I want to say that's the right page. It works out to be, I think it's a couple examples. It's like 4 of each style. Make sure you list out domain and range. Was it right? Did I write down? 44. 2440? Yeah, remember, when you're plotting these things, guys, you have to have 2 points on both sides. Don't just show curves. Tomorrow is when things get interesting. We got 3 different formulas, 3 different things. What's it? It's just, you just gotta make sure you remember which formula you're using to set it up. It's your written history. They make it dumb. Even tomorrow, when we get to a little bit more complex, where you have higher degree polynomial divided by lower degree polynomial, there's rules that you have to follow. Once you do it, it's pretty much the same.